Okay, this is the mould for one of the counterweights, using John Fleming's instructions. 3 blocks of wood. It's bored out with a hole cutter to 38mm down to about 40mm. There's a 6mm dowel sitting there, which will be drilled out for the adjusting rod to fit inside. The only thing I've done differently is I've actually lined the inside of the hole with ordinary packing tape, because I'm hoping that the epoxy won't stick to it as well as it would sticking to the timber. So I'm about to mix up some epoxy and start mixing in the lead shot, and that will be the next step. Mixing up probably way too much, in fact I know too much epoxy, but it's easier to, I'd hate to add any more afterwards, making a double mixture. Just mixing it up now. I've actually made up 50 grams of epoxy and 10 of the hardener. It's just standard West epoxy. Just give it a good stir and then let it settle a little bit. I'm going to follow the basic rules for both of these, whereas you pour a little bit of the epoxy into the mould and then some of the shot and then some more epoxy, etc, 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 which we'll be doing in a second. So, pour a little bit of epoxy down the hole. That's actually just enough to cover the bottom, and then we'll pour some of this shot. It's a very fine shot, as in very small. Got some in there, so, and then give it a stir with the old spatula. In fact, I put the wrong end in, but never mind. I'm going to use a slightly less big stick to make sure that the epoxy and the lead mix thoroughly. I think that's the basic gist of it. By doing that you also get rid of the excess air bubbles and whatever. Right, so a bit more epoxy. And then pour the rest, or some of more of this in. As you can see, it's a fairly simple exercise. It's at this point you start wondering whether you've actually drilled the hole not deep enough, but it looks like it will all go in now. Once you start mixing it in and stirring like I'm doing, it's becomes apparent it compresses quite well. So here we go. Oh, it's close. So once this has gone off, hopefully the wood will separate from the counterweight, and then it's drill the hole out, or drill that piece of dowel out, and that's ready to mount onto the hebridean. Still a bit more to go in there. What I've actually got here is slightly overweight anyway, so I'm not going to worry too much if not all of it gets in. You can scrape as much as possible up. Here we go. And I think that will be more than adequate for the weight which is required. And of course it's relatively easy then to take some off, because you can easily just cut some of the weight away with a knife or whatever. So I'm just going to get that nicely glued together, give it a good stir. I'm trying to get right down to the bottom, so give it a good old stir, like so. Here we go. And then that will set, hopefully, in the next few hours, and the job will be finished. Okay, this is the main counterweight, as you can see. I cheated here a bit. I used a yoghurt pot. It happens to be that our lacto-free yoghurt, the pot is almost exactly the right size for the counterweight. Other yoghurt products are available. So hopefully what we'll do is we'll just cut through here. This may be a total disaster, but it has set, and good. That's what I wanted to see, was that it just peels off. Because anything that makes that part of the job easier is to be recommended. Right, so that's the main part of the yoghurt pot removed. Hopefully you see that. Check it out. Just need to take the bottom off, which might be a bit more tricky, and then cut this rod flush and clean up these threads, which have got a little bit of epoxy on them, and there'll be an eye hook across there, which is all part of restraining the vane when it's not actually in use. Okay, that's now, apart from a coat of paint or some protective for the epoxy, because epoxy is not UV resistant. I've put the this eye here, which you can hook onto the main strut to restrict the movement of the vane. Put nylocks on the two bolts, and it sits there quite happily now, doing its own thing. File down the excess and the lip round here, so that's ready more or less to fit. The top of the pushrod, and the pushrod is actually a tube of carbon fibre. There's a dowel which goes 70mm down, epoxied in, and then there's a 5.5mm hole drilled through the dowel, and then this stud is screwed into that and then glued. Now this end is the fixed end, and there is a reasonably loose fit to allow the vane to rotate freely. It may be a bit on the loose side, but you can see the general idea. This end of the push rod is for adjusting the length to get everything lined up. You should end up about halfway along the stud that sticks out. It's the same principle as the carbon fibre tube. There is a dowel with a hole drilled through the middle of it. It's all epoxied together, and this goes into the arm which actually activates the rudder. Right, this is the foot of the main frame. I'm now going to replace or put on the actual actuator arm, which goes on there. This is a 6mm bolt with a nut holding it locked tight, and all we have to do is to re-engage the thread. The thread is now started, and literally all you have to do is rotate this on. It's probably easier if you didn't have all the push rods attached, but it doesn't really matter. It's not going anywhere, and just keep screwing away. Until you hit the end stop. Right, that's actually now jammed, so just rotate it back half a turn, 3/4 of a turn, until we are now facing, and that's about the position it will end up in its parked position. Right, I'm going to reconnect the push rod back to this, and it's fed through the middle of the turret, which is important, and then clips on there, and then you'd put one of the rings such as this here to hold everything in place. Right, the ring is now fitted on the what is the clevis pin, effectively, just there. You could use a small split pin as per normal. I guess that's up to you, but that's these rings are what are supplied by John in the kit. Here you can see the vane pivot and mount. The vane actually fits here. One of the important jobs that's required is a piece of string cord around the bottom of the counterweight to stop the vane moving more than 45 degrees. Now what I've done is I've drawn a 45-degree angle here, and if I move this out to here it's actually parallel, and over here it goes out to 45 degrees the other way. The best solution appears to be to feed the cord between the two bolts holding this plate, which gives you a nice easy balance. Once it's in place and you've adjusted it to suit, just do these bolts up properly, which is actually part of the hinge for the pivot. I've tightened the plate up, as you can see that's restricting the vane more or less to 45 degrees. I don't think it's particularly critical, but it's just to stop the pendulum rudder and the rest of it all bouncing around. Now you can see here the counterweight is here with the weight down that end. It's clamped on using these two standard clamps, and there's a grub screw here which can adjust the angle of the counterweight to the vane so that you can actually offset it so that it all hangs straight at the last when it's all ready. So that's ready to go now. I will just tie a knot at the bottom here, and that will be trimmed off in due course, and so I'll just trim and tidy these off eventually, but the main thing is at the moment that's holding that at 45 and 45. Okay, here you can see the vane pivot itself. These hinges, or pins rather, are made from bolts cut down and to fit, and there's a nut inside which is locked up against the pivot itself, allowing it free movement. It's a very straightforward exercise, very simple to do, and you can see the construction of the whole mechanism. I'm now going to fit the turret and the vane together. You just need to make sure that the bolt that was there is in line with the head like that, and then it's across. You can feel it go home, and then all you literally need to do then is to tighten up. Right, the push rod can now be connected to the pivot, which is done by literally bringing it up, and then it's a bit of a tight fit, which is good. Pushing it in. There we go. And then just fit a nice one of the rings as shown previously. and then the whole thing will pivot as per design. Okay, the ring is now in position, and if I move the push rod, you'll see the whole thing move as per design. You can adjust the travel of the push rod by adjusting the position of this in and out from the pivot base itself. So obviously the more you move it out, the more it actually moves. So if you're finding it's travelling a bit too far, just move it in a fraction. Fitting the vane to the mechanism is actually fairly straightforward. Just loosen this off, this clamp, and then fit wooden side to the rubber which has been glued to the pivot, and slide it on, and then just tighten up until it's in the right, well, put it into the right position and then tighten up like so. Dead easy, and you'll see then the whole thing will move quite happily. Here you can see the outrigger connected and the bungee connecting the frame to the outrigger. Same on both sides. I've used tie wraps here temporarily. I will be stitching them and whipping them and then cutting the tie wraps away. The control line that runs down to the frame, and obviously the other side goes to the opposite. So as the whole frame pivots on the pivot there, you can see that the lines are pulled to the tiller. And for storage, you can see the outriggers fold up and makes a reasonably tidy package.